In this video, we're going to focus on calculating the area of a regular polygon. So let's start with a regular hexagon. And let's say the apothem is, let's call that A. Let's say the apothem is 8 square root 3 and the side length is 16. With this information, go ahead and calculate the area of this regular hexagon. The area for any regular polygon, it's 1/2 times the apothem times the perimeter. Now, what is the perimeter of this particular hexagon? Because it's a regular hexagon, all 6 sides are congruent. So they're all equal to 16. So the perimeter is going to be 6 times 16. It's adding 16 6 times. 6 times 16 is 96. So the area of this regular hexagon is 1/2 times the apothem times the perimeter. Half of 8 is 4. And 4 times 96, that's 384. So the area is 384 times the square root of 3. And so that's a simple way in which you can calculate the area for a regular polygon. Let's work on another example. So let's say if we have a regular pentagon this time, and let's say the apothem is 9 units long, and the side length of the pentagon is 10.6. Go ahead and calculate the area. So first, let's calculate the perimeter. The perimeter for this example is going to be 5 times 10.6, since we have a 5-sided figure. And so 5 times 10.6, that's 53. So that's the perimeter. And the area is 1/2 times the apothem multiplied by the perimeter. So the apothem is 9. The perimeter is 53. So 9 times 53 times 0.5, that's equal to 238.5. So that's the area of the pentagon. 238.5 square units. Now, what would you do if you're given the side length of a regular hexagon? Let's say the side length is 20, and that's all you're given. How can we calculate the area of the regular pentagon? Not the pentagon, but regular hexagon. Feel free to pause the video and try it. Now, the first thing we need to do is calculate the angle. And to do that, first I need to draw a bigger picture. So this is the center of the hexagon. Let's call this point A, point M, and point V. So A is the center, and the distance between A and M is the apothem. Between the center and the vertex is the radius. And if this is S for the side length of a regular hexagon, MV has to be S over 2. Because the apothem is the distance between the center and it meets the side length. It meets this segment right at the middle. Let's call this B. So right at the midpoint between B and V, which means BM and MV are congruent to each other. So if BV is S, MV has to be S divided by 2. And let's call this theta. So we got to calculate theta first. Now, how can we do that? There's a formula that you can use. Theta is 360 divided by 2n, where n is the number of sides in the regular polygon. So we have a hexagon, n is 6. 2 times 6 is 12. And 360 divided by 12 is 30 degrees. So that's the angle. That's step 1. You want to calculate that first. Now, if you want to see it visually, break up the hexagon into 6 congruent parts. Now, the angle of a full circle, we know it's 360 degrees. And because there's 6 equal parts, we need to divide 360 by 6, which will give us 60. So each of these angles is 60 degrees. Now, if we draw a line here, which is basically what we did, that's the apothem, and we know that this part here is 60. 60 divided by 2 will give us this angle, which is 30, and that's theta. So that's why that angle is going to be 360 over 2n, because you're going to split this part into 2. So now that we have the angle, what do we need to do next? Let's focus on this triangle. So the angle is 30 degrees. And what is s over 2? Well, s, we know it's 20. So s over 2 has to be half of 20. So s over 2 is 10. Now, how can we find the other two sides using this triangle? If you have a 30, 60, 90 triangle, there are some things that you could use if you want to avoid using trigonometry. Let's say if the hypotenuse is 2. Across the 30, it's going to be half of whatever the hypotenuse is, so that's going to be 1. For the side across the 60, it's whatever this side is times the square root of 3. So this is going to be 1 square root of 3. So if this is 10, across the hypotenuse, across the 90 degree angle, which is the hypotenuse, it's going to be twice the value of this. So this is going to be 20. And across the 60 degree angle, it's whatever this is times square root 3. So this is 10 square root 3. So here's what we know so far. The apothem is 10 square root 3. All we need to know, or all we need to find at this point, is the perimeter. And to calculate the perimeter, it's simply n times s. We have a 6-sided figure, so n is 6, and the side length is 20. So the perimeter is 120. So once you have the apothem and the perimeter, you can now calculate the area. So it's 1/2 AP. The apothem is 10 square root 3, and the perimeter is 120. So half of 10 is 5. And 5 times 120, we know 5 times 100 is 500, and 5 times 20 is 100. So 500 plus 100 is 600. So the area is 600 times the square root of 3. And so as a decimal, that's about 1039.2 square units. So that's how you can calculate the area of a regular hexagon if you're given just the side length. Now let's work on another example. Very similar to the last one, but with a pentagon. So let's say the side length of the pentagon is 30. Calculate the area. So first, let's calculate the angle. The angle is going to be 360 divided by 2n. So for a pentagon, we have 5 sides, so n is 5. And 2 times 5 is 10. So the angle is 360 divided by 10, which is 36 degrees. So that's the first thing I'm going to do. Now let's draw the triangle. So this is r, the radius, this is the apothem, and this is s divided by 2. So we know that s is 30, because that was given to us. So s divided by 2 is 30 divided by 2, so that's 15. So I'm going to erase this, and let's replace that with 15. Now keep in mind, the angle theta is not this angle. It's this one, based on the way we defined it. So this is 36 degrees. So the other angle is 90 minus 36. So this angle, if for some reason you want to find it, is 54. Now we can use any one of those two angles to calculate the apothem. So let's focus on 36 because that's the first one we had. We really don't need this one, but you could use it if you want to. So which trig function, sine, cosine, or tangent, relates a and 15? So relative to 36, 15 is opposite to it, and a, the apothem, is adjacent to it. And tangent is opposite over adjacent. So tan 36 is equal to the opposite side, which is 15, divided by the apothem. So in this case, we can't use the special 30, 60, 90 triangle. We have to use trig to get the answer. Now, before we get the answer, I want to show you how to get this angle visually, for those of you who prefer it that way. So from the center, draw a line to each vertex, to every vertices of the pentagon. And so 360 divided by 5, let's see what that is. That's 72. So each of these angles is 72 degrees. Now, if we split this triangle into two parts, that's going to be 72 divided by 2. And so that's how you can get 36, if you want to do it that way. But I think it's just easier just to divide it by 2n. So if you have a 5-sided figure, just divide it by 10, and you can get that angle. So here's the apothem, and here's the radius of the figure. So let's calculate the apothem. Let's cross multiply. 1 times 15 is 15, and this is equal to a times tangent of 36. So this is the 36-degree angle, and this side is 15. So now to get a, we got to divide both sides by tan 36. (15) divided by tan 36 is 20.65 if you round it to the nearest 100th place. And so that's the apothem in this example. So now we can calculate the perimeter, and then that's going to help us to calculate the area. So just like before, the perimeter is n times s. So we have a 5-sided figure, and s is 30. So the perimeter is 5 times 30, or 150. So we have the perimeter, and we have the apothem. So now let's calculate the area. The area is going to be 1/2 AP. So the apothem is 20.65, and the perimeter is 150. So the apothem, I'm going to round it, is approximately 1550. So I rounded to 3 sig figs. I got 1548.75. But keep in mind that this is a rounded answer. So I'm going to round this one as well. Let's say if we have a 3-sided polygon, which is basically an equilateral triangle. And let's say the side length is 20. What is the area of this triangle? Now we're going to calculate it using two techniques. The first, a simple formula. The area of an equilateral triangle is the square root of 3 divided by 4 times s squared. And so in this example, s is 20. Now 20 squared, which is 20 times 20, that's 400. And 400 divided by 4 is 100. So the area of this equilateral triangle is 100 square root 3. And so that's the answer. But now let's use the other formula to confirm this answer. So first, let's calculate theta. So we know it's 360 divided by 2n. And for a triangle, there's 3 sides. And 2 times 3 is 6. So 360 divided by 6 is 60 degrees. So now that we have that angle, let's calculate the apothem. Now, if s is 20, this side, s divided by 2, that's 20 divided by 2, so that's 10. Now, this other angle is 30. So we have a 30, 60, 90 triangle. So if you want to use geometry to find a, here's what you can do. So this is 2. Across the 30, it's half of the hypotenuse. Across the 60, it's this number times the square root of 3. So notice that we have this value. How can we find a? Well, if we have this value and we need to get that value, we need to divide by the square root of 3. So it's going to be 10 divided by the square root of 3. So the apothem is 10 over the square root of 3. Now, if you want to use trig to get that same answer, we could use the tangent ratio. Tangent of 60 is equal to the opposite side, that's opposite to 60, divided by the adjacent side, which is the apothem. Now, tan 60, if you type that in your calculator, you should get like 1.73, which is the square root of 3. So if we cross multiply, 1 times 10 is 10, and this will be a times the square root of 3. So notice that the apothem is 10 divided by the square root of 3. So both methods can work. So remember SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is equal to the opposite side divided by the adjacent side. Now let's calculate the perimeter. So it's n times s. For a triangle we have 3 sides, and s is 20. So 3 times 20 is 60. So the area is going to be 1/2 AP. The apothem is 10 divided by the square root of 3, and the perimeter is 60. Now 1/2 of 10 is 5, so we have 5 times 1 over square root of 3 times 60. Now 5 times 60 is 300, so we have 300 divided by the square root of 3. Now let's rationalize it. Let's multiply the top and the bottom by the square root of 3. The square root of 3 times the square root of 3 is the square root of 9, which is 3. And 300 divided by 3 is 100. So this will give us the same answer. 100 square root 3, but just a lot longer. But it does work for any regular polygon, this formula. Let's say if we have a regular hexagon, and this time we're not given the side length, but we're given the radius of the hexagon. And let's say the radius is 10. Calculate the area of the regular hexagon. So let's draw a picture. So we're given R, that's 10, and we don't know the apothem, and we don't know s over 2. However, we can find the angle. So the angle is going to be 360 divided by 2n. So n in this example is 6. And 2 times 6 is 12, so 360 over 12. That will give us an angle of 30 degrees, which means this is 60. So now that we have the angle, we could use the 30, 60, 90 triangle to get everything else. So across the 30, it's going to be half of the hypotenuse. So half of 10 is 5. Across the 60, it's this number times the square root of 3. So it's 5 square root 3. So that tells us the apothem is 5 square root 3. And if s divided by 2 is 5, s has to be 5 times 2, which is 10. So let's draw a picture. So this is 5, but this is 10. And this is 5 square root 3. Now let's calculate the perimeter. It's n times s. So n, that's 6. We have 6 sides. And s is 10. So it's 60. So the area is 1/2 AP. So the apothem is 5 square root 3, and the perimeter is 60. So half of 60 is 30. And 30 times 5 is 150. So the area is 150 square root 3. And so that's how you can calculate the area of a regular hexagon if you're given the radius. Try this problem. The radius of the circle is 24 centimeters. What is the area of the equilateral triangle? Now the radius of the circle, you need to realize, is the apothem of the triangle. And this r is the radius of, let me do that better. That's the radius of the triangle. and this is s over 2. And here we have theta. So theta is going to be 360 over 2n, and n is 3. So 360 divided by 6 is 60. The apothem, we see that it's 24 centimeters. And so let's draw the triangle. So this is 60, this is 30, and this is 24. So if that's 24, the hypotenuse has to be twice the value, it's 48. And across the 60, it's whatever the value across the 30 is times the square root of 3. So we know that s over 2 is 24 square root 3. So s is twice that value. So s is 48 square root 3. So now that we have s and a, we can calculate the area. So the perimeter is going to be ns. So that's 3 because we have a triangle. So 3 times 48 is 144. So the perimeter is 144 square root 3. So now let's calculate the area. So the area is going to be 1/2 AP. The apothem is 24, and this is the perimeter. Half of 24 is 12, and 12 times 144 is 1728 times the square root of 3. So this is the answer. Now let's confirm this answer using that other formula. So the area of an equilateral triangle is the square root of 3 over 4 times s squared. And we have s. So s is 48 times the square root of 3. Now 48 squared, that's 2304. And the square root of 3 squared, that's like the square root of 3 times the square root of 3, which is the square root of 9, and that's 3. So we got to multiply that by this. So 2304 times 3, that's 6912, divided by 4, that will give you 1728 square root 3. And so you can get the same answer. So now let's talk about what we've learned in this video. So you now know how to calculate the area of any regular polygon if you're given just a side length, if you're given the apothem, which is what we did in the last problem. The apothem was the radius of the circle, or if you're given the radius, which we did like 2 problems ago. So now at this point, you should be able to calculate the area of any regular polygon in many different ways. So if your teacher gives you the side length, the apothem, the radius, you now know how to calculate the area from each perspective. So that's all I have for this video. Thanks for watching, and I wish you well on any tests you may have coming up.